environment is not very amenable for drone flight. So for various reasons, not accessible by foot, almost no part of it. B, there's always ash in the air. It's very hard to fly drones through that air. And it's just a huge area. It's a volcano. The entire area that it covers is around 75 square kilometers. And all of it had to be mapped.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 365. Can a drone prevent the loss of life from volcanoes? For that question, we head to Zurich to speak with David Adjiashvili, founder and vice president of products at Drone Harmony. Drone Harmony is a software-as-a-service company that automates mission planning in the most challenging vertical inspection scenarios. Their software enables cost-effective deployment of drone technology in industries where existing technologies are unable to deliver. And it enables pilots with minimal training to collect high-quality, reproducible data. As a Swiss company, Drone Harmony understands that the safety of your data is essential, and even deploys their system on your premises. The company was founded in 2016 by a team of problem solvers with a passion for drones, software, and automation. In addition to being one of those founders and chief scientist, David is also senior scientist at the Swiss Federal Institute of Technology. His field of expertise is algorithm design and mathematical optimization, and he's been responsible for algorithmic development of the Drone Harmony Mission Planner. David received his bachelor's degree in computer science from the Tel Aviv University and his master's in applied mathematics from the Weizmann Institute of Science. He completed his PhD in mathematics at the ETH Zurich in 2012, specializing on algorithm design for planning and optimization problems. He has since been employed in the mathematics department at ETH and worked on various research and industrial projects in the field of optimization. In 2021, Drone Harmony assisted Darrell Group KK and the Kyoto University in generating an up-to-date, high-resolution 3D model of Japan's Sakurajima Volcano. Sakurajima is one of the world's most active volcanoes. It is located in the south of Japan, with approximately 600,000 people living within 4 kilometers. Scientists are predicting a major eruption within the next 30 years. The project team used Drone Harmony to develop the 3D model and run various simulations for disaster prevention and response, with the goal of developing evacuation and mitigation plans for all potential disaster scenarios. Mapping a terrain is typically a straightforward process, but the project team quickly learned that a large geographic area, much of which is inaccessible, hostile, and constantly changing, poses several challenges. In this episode of the Drone Radio Show, David talks about Drone Harmony, the company's 3D mapping services, and how that technology can be used to accurately map and model large vertical geographic areas. But before we hear from David, I have a special announcement for those who are regular listeners and supporters of the podcast. I've had several suggestions by listeners to create a space where we can connect with the show and with each other and talk about all things related to the drone industry. In the coming weeks, I'll be releasing our very own community of Drone Radio Show advocates. It'll be a place where we can connect, talk about current shows, bounce around episode ideas, get some behind-the-scenes insights, and have some fun. I'll have more information in the next 2 weeks. And by the way, if you have a great story on the use of drones that you'd like to share in a podcast, contact me at randy@droneradioshow.com. So let's find out how drones can prevent the loss of life from volcanoes with David Adjiashvili of Drone Harmony. Let's pick up the interview where I asked David to introduce himself.
My name is David Adjiashvili. I'm the CTO and co-founder of Drone Harmony, and I manage a lot of the technical aspects within designing and implementing our software platform, and also I'm involved in some of the business aspects of the company.
David, tell us about Drone Harmony. What does the company do?
So Drone Harmony is in the business of software for drones. We develop software for the purpose of data acquisition. We focus on that part of the value chain of the commercial drone market. So by this, I mean flight planning and flight execution. And our software enables our customers to scale drone data acquisition across a variety of different use cases, as well as across a large number of assets within the organization, and make sure that they get the same type of quality across the different assets, hence allow the scaling of the drone, let's say adoption of drone technology within larger enterprise customers. So that's really our focus.
Tell us about the type of services that Drone Harmony provides.
Actually, Drone Harmony started as a mobile app, and as a mobile app, we actually wanted to cater, in a sense, to all possible commercial use cases. But of course, with the time, as we've matured and started looking to specialize, we've picked a couple of use cases where we felt that our technology was, let's say, the most suited to provide the biggest value. And to name several key use cases, so definitely vertical inspection, so inspection of 3D assets, things like buildings, communication towers, complex terrain inspection. So when we talk about cliffs, hills, even in the agricultural space, when we talk about things like vineyards, anything that's not just flat, all of those use cases are of interest, or let's say our software is well suited for those use cases. Open pit mining is another one. And we're currently entering into the electric grid market as well. So that meaning transmission and distribution lines and dedicated workflow for these kind of things. So to summarize, most things 3D, most things vertical is where we really focus our attention on.
There are a number of companies that provide similar services, but what makes Drone Harmony different?
The software that Drone Harmony designs for those kind of use cases, basically, the unique aspect of Drone Harmony is reliance on 3D interface and 3D data throughout the entire data acquisition process. So we usually think about 3D as the output of the process. So we would collect some data using some sort of software that's usually inherently 2D or map-based, or maybe we'll fly manually and collect data, and then we'll generate data products that are 3D. Things like 3D models or point clouds, etc., and that will be a basis of some sort of digital inspection workflow. In Drone Harmony, we kind of put this upside down and said we actually need to start from 3D if we were to really automate flight planning around complex vertical infrastructure. So from day one, actually from about six and a half years ago, when we first released our first prototype on the market, our software was a 3D flight planning software. So you'd have an interface that's very similar to, some people might know, software like 3D Max, where you have 3D objects you can manipulate, define, and interact with within a 3D environment, and use that for several purposes. So in Drone Harmony, the purpose would be flight planning, and then, of course, in the mobile app, flight execution. So the fact that our software is built on this technology allows us to really pre-plan flights in a very efficient manner for very complex use cases, and to include various forms of, let's say, obstacle avoidance are, let's say, unique, because we can define an environment, a complex environment during the pre-planning phase. We don't have to encounter the environment necessarily, only when we execute the flight. So that's one aspect. And of course, that has two main aspects. That in its own right has two main parts. One is the fact that it's a very visual platform. So despite the fact that the missions might be very complex, the fact that you can look at them in 3D just gives you a much better idea of what the flight trajectory will be, what will be the angles of attack of all the images versus the asset that's inspected or mapped. And the other aspect is, of course, the fact that this data is known to our software ahead of time. It allows us to pre-plan automatically various types of missions that you would otherwise not be able to do in a, let's say, two-dimensional flight planning software. So that's really the key differentiator. And of course, the bottom line for the customer is not necessarily technology. The result is that we want to make sure that a large organization with very different skill sets across the organization, it can take many people in that organization and train them to do exactly the same data acquisition. That's really the bottom line for us. We don't want to design a tool that's only for the expert. It should be a tool that any technician or engineer in a company should be able to use to perform the type of data acquisition that the company needs.
In 2021, Drone Harmony began working on a volcano prevention project. It sounds interesting. Can you tell us what it is and why it was undertaken?
The project was executed by a partner of ours, Daryl Group. It's a company in Japan that specializes on very large scale and very complex data acquisition tasks using drones. So you can imagine this is a company that's been building their own drones since a couple of decades, and they were retrofitting DJI drones to have double the flight time by stacking, several versions of them on top of the other. So it's really a company that has a lot of very deep engineering skills. And because of that, they were both interested and able to deliver on very complex mapping and inspection type missions. And this volcano mapping project was exactly one such project. So Daryl Group is a company out of Japan that's doing these things. And we collaborated with them on this project in that we provided them the tools that allow them to acquire the data around the volcano that eventually allowed them to create the 3D deliverables that they needed for the use case.
Where is the volcano located?
The volcano is in Japan. So the volcano is called Sakurajima. It's an extremely active volcano, as in on a daily basis. There aren't huge eruptions on a daily basis, but it's active on a daily basis. There are small eruptions essentially on a daily basis. And there is the expectation that a huge eruption can happen essentially anytime. And because of that, it's very important to monitor the activity of the volcano and map as much of it as possible ahead of time so that good evacuation plans for the underlying villages and towns just at the foot of the volcano can be pre-planned, and the evacuation paths can be pre-planned for various scenarios of eruptions.
What was Drone Harmony's role in the project?
Key activity in the project was to create a very detailed 3D model of the entire volcano, including the pit of the volcano and every part which is essentially extremely active around the volcano. And you can imagine that this environment is not very amenable for drone flight. So for various reasons, not accessible by foot, almost no part of it. There's very few parts you can access. B, there's always ash in the air. It's very hard to fly drones through that air in a safe way. So that's another part of the planning that needed to be done. And other than that, it's just a huge area. It's a volcano. The entire the entire area that it covers is around 75 square kilometers. And all of it had to be mapped for the project to be successful, or at least all of the parts that are relevant for the populated areas around the volcano had to be mapped. So that's at least half of it. Drone Harmony provided the software to plan and execute those missions.
Tell us about some of the challenges that you had to overcome.
For the flight planning part, the challenges were the following. So first, it's a very, very steep volcano, very, very uneven terrain. It has various cracks and dents, and it's not easy to plan a mission for any significant size of it, which is not using some sort of surface model of the volcano. So that was one challenge, and it's not really a use case in which you can rely on standard available data like SRTM data, things that are available in standard terrain-aware flight planning solutions on the market. One really needed to use a custom surface model to base flight planning on. So that was one challenge. The other challenge is to be able to plan the different captures. So obviously with such huge area, you cannot really plan one big mission, then just execute it in parts with some sort of, workflow in which you charge batteries and have the drone come back and so on. So those kind of workflows are useful when you have maybe areas in the order of magnitude of 1-2 square kilometers. But as soon as you reach such huge areas, you really need to have some way of subdividing the tasks into the whole task into smaller ones, planning each one. And in each single smaller task, you might have this kind of workflow in which some sort of multi-battery workflow where you would rely on the software's ability to, execute a multi-battery mission. So this high-level planning of partitioning the area, being able to plan for each one, that was another challenge that needed to be addressed. And maybe the biggest challenge of all was that a large part of the volcano, especially around the pit of the volcano, the parts which are most important to map properly, are not accessible at all for neither foot nor car in any way. So for many of those points on the volcano, the closest points that was reachable was several kilometers away from that point. So that meant to capture data around those areas, you really needed to start the drone several kilometers away, fly over, do the mapping, return in a safe way, etc. So that was another big challenge. So it wasn't possible to just partition the whole thing into a grid of rectangles or something like that and just work in each rectangle on a different day. That was not the type of workflow that could work in this use case. So those are some challenges.
How did you overcome that last challenge?
One had to find places where you could start the drone on the perimeter, fly into the area, perform a terrain-aware flight planning mission, where sometimes you would need an elevation change of up to 500 meters, so that you'd be flying not just straight, you'd be flying up and straight at an angle of sometimes 30, 40 degrees, way up the steep part of the volcano just before the pit. Then perform some small part of mapping, whatever the battery would still allow you to do, fly back, and then repeat this operation over and over again until all of this inner part of this inaccessible area was covered.
What's the current status of the project?
Almost all of the volcano was already mapped. There are still parts that weren't mapped, and they're scheduled to be mapped in the upcoming years. But the current data is already sufficient for planning the needed evacuation routes and plans for the largest populated areas around the volcano. The plan is actually to continue performing this work on a, let's say, maybe not an annual basis, but every couple of years to create new up-to-date models of the volcano. And the idea is really to use the 3D models not only to be able to simulate the flow of the ashes of the lava and all of the things that get erupted during a large-scale eruption, but also to measure the formation between successive models and to be able to predict from that where an eruption can happen. So the scientists that are behind this project, and there are a few from Kyoto University, for example, that are involved, as well as the Ministry of Land and Infrastructure of Japan, that are interested in using in various ways that actually 3D models that are created from this to both predict as well as to plan and simulate for various eruptions.
Did flying over the pit of the volcano pose any hazards?
What our partner told us is that there were days where there was just no way to fly anywhere near it because the ashes were so thick that they would just clog the motors too quickly before they could do any sort of significant work. So you can imagine there were some days where there was just no way to fly at all. It was never clean air around that part, and they always had to, have spare parts and replace. And that's another reason why this team from Darrell Group is so professional. They are the type of engineers that can essentially replace motors if needed in the field, etc., from DJI drones and make them work. So there was definitely the ash challenge, and that was not only above the kind of the pit of the mine, but rather in various places around it. And of course, closer to the ground, there was also a heat issue, but To be honest, I'm not sure how much that was the limiting factor, because in those areas, the mapping was done at a sufficient altitude to prevent any of that. And sometimes they even had to prevent flying above certain areas altogether to eliminate risks of component meltdown and clogging.
Was there anything special about the drones themselves?
So interestingly enough, initially the plan was to use a very customized drone rack, one which has a very high endurance, can carry a very large payload, etc. But then the plan was changed and they started to use off-the-shelf DJI drones just because they knew that the risk that they will lose drones is very high. They just couldn't afford the risk of building one payload and one system, and that system being lost, and then the whole project is paused for a year or two before they can rebuild the same system again. So actually, they eventually ended up designing a workflow that was fitting an off-the-shelf drone. In fact, they were using DJI Inspire drones with X4S or X5S cameras. This is something I don't remember at the moment.
Were there any surprises, pleasant or otherwise, with the way the project has unfolded?
Interestingly, they do have the 3D models, but the crux of the analysis was creating those flow models of all the material that's erupted from the volcano in case of an eruption. And the idea was really to simulate all possible scenarios so that if an eruption occurs, they can just pull out the scenario that occurred and use the evacuation plan for that scenario. The evacuation planning is such a computationally intensive task that they realize they cannot just wait for it to happen and then start computing and planning. They have to pre-plan essentially for every possible eruption within a reasonable space of possibilities. So that's why all of this computation is a very, very long task. And they're still actually working on this. As far as surprises in the project, so this was the first time that Drone Harmony was involved in such a complex project as far as a mapping project. And I was definitely surprised as to how many challenges such a large project brings beyond just, let's say, the operational challenges you might think of the top of one's head is, okay, a lot of time that needs to be invested. We need to make sure that we have enough equipment. We need to be able to access every place. But some of the challenges were very unexpected. So, for example, before this project, the workflow of working with surface models within Drone Harmony was such that you would upload a file or upload a model, and that model would sit there and you could use it for flight planning. But then tomorrow you have a new model or you have a new tile of the same one, you'd have to upload it again. And those things kind of lived independently. And that was a challenge because what turned out happening is when we think about planning for a region, terrain or flight planning, we think that we need for that region to have a good surface model, and then we'll be able to plan in it. But the fact of the matter is that you might need to also plan the approach flight from somewhere very, very far away from that single point, from that area, because that area might be exactly in this inaccessible area. So this kind of made us think of a paradigm shift in the way how we within Drone Harmony think of surface models and terrain models for flight planning, from them being local things, small things that you load to perform flight planning in a single area, into what they are now in Drone Harmony, and that's layers. The same way like a map is a layer and it's available everywhere, and wherever you navigate around, let's say Google Maps, you see the corresponding part of the map and that part is loaded onto your screen. The same way terrain and surface models need to work, because a lot of times there are dependencies that are across bigger geographic regions than you would think that would be needed for a single mapping task. So that was one very interesting learning that we had in this project. And if you look at the missions that were planned for some of these capture areas, you can see a certain patch that's being mapped in one side of the mountain. You see the takeoff location almost on the other side of the mountain. So you need terrain data now across this entire geographic area to be able to do the safe flight.
It sounds like Drone Harmony was involved quite a bit in the actual planning and execution of the mission, maybe more than what might be expected when we think of software as a service. Is that a fair assessment?
Yes, in fact. So our partner was very well trained in using Drone Harmony, but still, because of the challenges, some of which I just discussed with the previous question, they needed continuous support. So they needed continuous support with managing the surface models that they were using for the flight planning. So they received a lot of help on that front, as well as advice on how to perform the flight plan itself. So we were in constant contact with the partner in this project. We did none of the flight execution ourselves. We wouldn't be able to do that just because we need also the expertise of operating in such a hazardous environment. But we were always there for them on the phone and on calls during the season in which they performed those flights. And it was several months of continuous activity on the mountain. So we were definitely involved in that sense, yeah.
Going back to the mission planning workflow, did the Drone Harmony software recommend the flight path to map the inaccessible areas? Or did you guys help out with some analysis and some human intervention?
While the project was running, it was more that we were providing human intervention, and the visual interface that Drone Harmony provided was kind of an enabler of doing semi-automated, let's say, or kind of manual, but based on visual inputs type planning for these things. So the engineer who was responsible for flight planning would kind of scout within the Drone Harmony software around and see how different flight plans look like if a takeoff location was selected one place versus another, what kind of flight time that would be, what kind of elevation changes that would mean, how does this comply with kind of DJI restrictions on various parameters of flights, of long and complex flights. So that was, let's say, the degree at which Drone Harmony was enabling the planning of those, let's say, complex cases of faraway takeoffs and things like this. It has, however, inspired various ideas that since then kind of entered into the product and are still being developed into automating some of these things, just because we do believe that huge scale, let's say very large scale mapping is a use case that has still some gaps in the market. And it's a very, very important use case to develop automation software for. So this project has taught us a lot on how these kind of workflows can be improved. And we have made improvements since we've actually done this project.
Well, that leads me into my next question about some of the lessons learned. You already mentioned integrating more automation. Any others?
One key takeaway from the project was definitely the fact that it's very important to be able to treat, let's say, the baseline data. When you perform flight planning, it might be based on map data, or it might be based on shape data like KML files or something like that, or it can be surface models like in this case. It's very important to choose the right architecture within the software to enable large-scale operations. So I'll give you a couple of examples. So for example, if we're talking about communication towers, so cell towers, those are assets that are, let's say, isolated. So there's one communication tower here and it's in one place and it covers a very small geographic area, and the next one is somewhere far away. So it's okay to have an architecture where you store kind of sites, each one containing maybe one communication tower. Whereas when we talk about large-scale mapping, it's a very different use case where we don't a priori have any partition of the entire space into meaningful parts, like this is one tower, that another tower here, there is nothing like this is one parcel that needs to be mapped, and that's another parcel. One user might partition it in one way for one reason, and another user might need to partition it in another way for another reason. It can be accessibility. It can be just the type of data products that they need to provide. So that taught us that we cannot treat everything the same way. So terrain, surface models, they really need to be like a layer. The same way like a map is a layer. We don't load a 1 square kilometer rectangle of a map when we zoom in Google Maps in a certain area. We just zoom in where we need and the map loads for us automatically in that area. So that's really one paradigm shift that we've learned also from this project in parallel with others. And there's other types of infrastructure data that fit into that category. For example, large-scale infrastructure like distribution and transmission lines, it's very hard to discretize them. They are covering large areas, and it's difficult to kind of make singleton items out of them. And it's much more natural to have them just as a layer that lives within the software. So from the kind of user experience and software architecture perspectives, we've learned really a lot about that kind of things from this project. Another thing that we've learned is how important it is to provide tools for management of, let's say, multi-flight, or let's say projects which are composed of various smaller parts. Like in this case, the entire mapping of the volcano was composed of hundreds of flights, of smaller flights. And if the software doesn't accommodate certain workflow that allows you to manage in a reasonable way, in a reasonable interface, a large number of parts within a large project, that's just not going to be a scalable solution for any sort of large scale data acquisition, whether it's mapping or let's say inspection of a large amount of distribution towers for that matter. So those are really the types of learnings that were for us eye-opening in this project. Before this project, we very much were focused on small assets, if that makes sense. They're not small by any means, but smaller in compared to this asset. If you think about the volcano as an asset, that's a 75 square kilometer asset that we really need to model. So totally different challenges arose and informed a lot of our R&D focus as well.
What's next for the project?
At the moment, the project team is focused more on the analysis of the captured data in the first iteration. And based on the results of that, they will plan the next capture. And the exciting thing is that the next capture will already be based on a workflow that's much more suitable for those kind of workflows. So while Drone Harmony was the only product that they could use 2 years ago when they performed the project, it has made a lot of strides towards even better workflow for such use cases. So I'm excited to see how the next iteration, I expect it to be an order of magnitude easier even from the first iteration with our current solution. And we're building, say, more features to facilitate that further. So at the moment, the project is at the stage where they analyze the data and perform the analytics part of it, which is planning things like escape routes for populations living at the foot of the mountain, as well as creating other deliverables based on the 3D model that they've computed. As there is a plan to perform this kind of mapping on a regular basis, I expect in a couple of years' time them to pick up the mapping task again and to create the next model, because this volcano is changing literally on a daily basis, both in its shape and in its activity. So they really have to monitor it regularly.
Does Drone Harmony have other projects of this scale or challenge on the drawing board?
So there's a couple of large-scale mapping projects that we're looking at and that are planned to start in this year. There are some that are even larger than this one. They are not as complex as in there are fewer aspects like, let's say, volcano ash that we need to worry about and stuff like that. So it's not about mapping volcanoes necessarily, but it's about mapping huge areas. Think about them as mapping areas the size of cities or even small countries. And how could one define the workflow? So that's, again, an increase in order of magnitude in the volume of work that needs to be done for the data acquisition. So we realized that when we moved from 100 square kilometers roughly, which is this project, to 1,000, there's another set of challenges that appears. And we're now working on a solution that will help address this next set of challenges. So actually our next mapping project will be even larger. Again, of course, we will not do the data acquisition ourselves, but we will provide the software. And hopefully we'll be able to report on those projects starting from next year. But we're definitely very seriously engaged in this market. And I believe this is a market that will thrive in the next couple of years.
Is there anything that we missed that we should talk about?
Large-scale mapping, which is something we've talked about a lot. It's just one aspect of the complexity of mapping that we're starting to see in the market. So some aspects of, let's say, more complex mapping missions come from scale. So how large the area is it needs to be covered, what parts are accessible, what parts aren't, etc. But we have seen another dimension along which complexity can increase and does increase significantly, and that's the shape of the asset. And that's actually some aspect that I actually forgot to mention, but in this project was also a factor. When we talk about mapping an area, which is terrain-aware mapping of an area, we usually think about kind of hills that change gradually when we fly along them. But a lot of the most important types of terrain to map are exactly the ones that are extremely sharp, that have extremely sharp slopes and very non-uniform shapes. So things like cliffs above infrastructure, things like mountainsides where rock slides can happen, etc. So this is a space in which Drone Harmony has put a lot of effort in as well. So that's not about large scale, it's about complex shapes of those assets or terrains. And Drone Harmony has developed quite a few features to address those specific use cases in the best way possible as well. We have a feature for that in our publicly available product it's called HillScan, that's designed for these kind of challenges. And that's another part of, let's say, complex mapping that I wanted to not forget and be mentioned here. If somebody is interested in those kind of use cases, cliffs, mountains, very, very sharp terrain, they're more than welcome to also reach out or look at our website and see what we can offer in that regard.
And for my final question, David, what message would you like to leave regarding the future of the drone industry?
I think the drone industry is on a very, very healthy path towards healthy growth, healthy and steady growth. I think that we have passed the stage of, let's say, unhealthy excitement about the potential of the drone market. And we're into the stage of realization of where the real value in utilizing drones in the commercial space lies. And that value is huge. And I think that both enterprises and technology firms are starting to pick up on those really valuable parts of the market and start to provide kind of real sustainable value for customers. So I think that the drone market is at the best place it's ever been, and it's only going to improve from here.
That's it for episode 365 of the Drone Radio Show. I hope you enjoyed hearing from David Adjiashvili of Drone Harmony. I want to thank David for taking the time to speak with me. If you want to learn more about Drone Harmony or want to connect with David, check out the webpage at droneharmony.com. If you like the Drone Radio Show, then I'm sure you're going to like being part of the community of Drone Radio Show advocates. Look for more information in the coming weeks. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.